Okay, but I could not able to hear you, sir.
Sir, we are able to hear to you, sir. It is audible, sir, loud and clear, sir.
Yeah, sure. Thank you.
So can we start, sir?
But I could not able to hear you, sir, from your side.
Hello, sir.
Yeah, sir, I'm audible or any disturbance in my voice?
Sir, it is clear, sir. You are able to.
Yeah, now I can able to hear you. So my
Yes,
voice
sir.
is clear to you all, right?
Yes, sir. It is clear, sir. Now it's clear,
Yeah,
sir.
sure. If you're having any issues, please let me know.
Sure, sir. We'll let you
Yeah,
know, sir.
sure. Yeah, sure, sure.
Can we start, sir?
Yeah, we can start. No issue.
Yes, sir. Good afternoon, participants. Welcome back to the afternoon session of fourth day of ATAL AACT ATAL FDP program. Today we have with us Dr. Vijay Kumar Krishnasamy, sir, to present his views on electric vehicles and overview. To tell about sir has completed his bachelor's in electrical and electronics engineering from Coimbatore Institute of Technology, Coimbatore, and his MTech in power system from National Institute of Technology, Trichy, and PhD from NIT Trichy in the year 2012. His research interests includes power electronics and drives, home energy management system, smart grids, Internet of Things, applications of machine learning and artificial intelligence to energy system, embedded controllers, and industrial electronics and renewable energy systems. The following are few of the honors and awards and recognition which has been obtained by Vijay Kumar sir. He is a visiting professor for research given by University of Swansea, Canada in the year 2017. Is a recipient of Shastri Indo-Canadian Fellow for Research Collaboration given by Shastri Indo-Canadian Institute in the year 2017. Is a young faculty fellowship for project grant given by Ministry of Communication and Information Technology in the year 2016, and he has received a Young Scientist Award for Startup Research Grant given by SERB DST in the year 2015. POSOCO Power System Award for doctoral thesis and listed among top all IITs and NITs for PhD thesis given by POSOCO and Indian Institute of Technology, Indian Institute of Technology, Delhi. Is a postdoctoral fellowship from Nanyang Technology University, Singapore, for his postdoctoral research given by Nanyang Technology University. Is a MHRD fellowship for PhD for fellowship given by Ministry of Human Resource Development, Government of India, and he is a professional member of IEEE, IET, IAENG, and International Association of Computer Science and IT, and he is a life member of IE and ISTE New Delhi, and he has been a reviewer in SERB DST project proposal at DST, reviewer of IEEE, IET, elsewhere, Springers, and other journals and conferences, and is the professional in charge for social service groups at IIDM and professor in charge for gardening services at IIT DM. And he has published one book in the title Intelligent Paradigms for Smart Grids and Energy Renewable Energy Systems, and he has published many papers from during his tenure, and he has supervised many students who have been during his tenure. And I request him to take over the session and give us to share his expertise in this session, sir.
Yeah, thank you. I'm audible now. Are you able to hear me, right?
Yes, sir.
Yeah, sure. Good afternoon to all of you. It's my great pleasure to be a part of this FDP program. I'd like to thank the coordinators of this program for the invitation. It's my pleasure to meet you all in this platform, online platform. I hope everyone's safe and healthy. In this FTP, I'm going to discuss about electric vehicles, the opportunities and challenges. So as an electrical engineer, how can I look the electric vehicles technology and what are the areas I can focus in it, and I do contribute something towards the development of the technology. I have shared my slides. I hope you can able to see my slides. So my slides are moving.
Yes, sir. It is moving.
Sir, now?
Yes, sir.
How also it's moving now, sir?
Yes, sir. Yes, sir.
Yeah, sure. Okay. So electric vehicles. So whenever we are going to start with electric vehicles, even we hear a lot of notifications and announcement from the government. I hope all of you have heard about it. Even 2030, almost they are going to make 1/3 of the vehicle from electric vehicles. So that's what even most of the industries in India, automobile industries, they are moving towards the electric vehicles. Even in between, even if you have heard last week or 15 days back, even they have announced one more. They have announced that the government announced that all the four-wheelers and two-wheelers, they are going to make it with ethanol fueled. I mean, the ethanol instead of petrol, you can use the ethanol as source to run your vehicle. But most of the automobile companies, they have they made a lot of comments. Even some of the companies they mentioned that they could not able to make the engines, IC engines with ethanol fueled. So if that's what even if we have seen that this sugar companies, they get into focus nowadays because they are the larger producer of ethanol. But this ethanol vehicles, if we have discussed, we cannot use the ethanol blended petrol for your vehicle directly. Even you should have the different IC engine for it. So you need to modify the design of the IC engine. For that also, even the automobile companies they haven't focused much. Why? Because if they want to make any change in that IC engine design, their total assembly line will be affected. Actually, when we talk about the automobile companies, if they have invested invested for BS4 or BS6 or BS5, then almost I mean, if they run that assembly line for 5 years or 10 years, then only they can able to make a profit. So within 2 years or within 3 years, if you are keep on changing the technology in that IC engine design, or if you are changing the regulations, severely the automobile companies will affect. So that's what even this ethanol blended fuel is not very much welcomed by the automobile companies. But when we talk about the electric vehicles, most of the companies they are ready to adopt the electric vehicles. But we cannot say within a year or within 2 years we can able to see the electric vehicles on the roads. But it will take almost 5 to 10 years to see a lot of vehicles on the road. So even if you are changing the technology, almost it may take 5 to 10 years of time to adopt it. Even if you talk about the telephone also the same way. Earlier, just we had the landline phones, then just we have shifted to the mobile phones. Then now the smartphones are coming to the picture, and they are making a lot of revolution in the telecommunication. Also plays a huge role in the automobile industries. Even most of the four-wheelers, passenger vehicles, as well as two-wheelers, they are ready to adopt this electric vehicles technology. The major drawback with this electric vehicle technologies, one is the battery technology, and when in the consumer perspective or customer perspective, the speed range and the pickup. So these are the bottlenecks for the electric vehicles. So those things we will discuss in this session. So when we come into the history of electric vehicles, it's very interesting to see that the electric vehicle technology is not a new technology. Even it's a 100-year-old technology. Even the 100 years back, they come up with this electric vehicles, not exactly on that battery operated electric vehicles, but in the form of electricity. They have come up with the first electric vehicles in 1890 itself. So we can say almost EV is a century back technology, even 100 years old technology. It's not a new technology, but there are a lot of new features added into it, and just because of this other technologies, now we are focusing to revoke this electric vehicles into the picture. So now we can see here, earlier they have used the horses or even the bullock carts for the transportation. Then the first crude oil based vehicle come into the picture on 1832. In 1832, just you can able to see my slide now, right? In the second slide. Hello. Just I'm asking the participants, you can able to see my second slide?
No, it is not.
Or not?
It's still in the first slide, sir.
It's not moved.
Yes, sir.
Oh, okay, sir.
So we can have full screen presentation.
So what I can do is, if I make full screen, then that's the issue here. The slides are not moving. So what I can do is, I can share my entire screen, so that would be better.
Yes, sir. Now it's okay.
Yes, sir.
I hope you can able to
Yes, sir.
now.
It's fine, sir. It's fine.
Sure. Thank you. Now they have come up with that crude oil based electric vehicles. So instead of using the petrol, just they have used the crude oil to burn, and they get electricity from the turbine. Then they have used that electricity to drive the vehicles. That means they do not have the IC engine. Instead of IC engine, just they had a electric motors to drive the wheels of the vehicle. So that's what they say, it's a crude oil based electric vehicle. Then in 1890s, just they have come up with the first, officially they have come up with the first electric vehicle. This electric vehicle again run with the crude oil, or we can say it's the gas. So in 1899, that means 1890, this electric cars get popularity. Why? Because it won't give the any emissions, gas emissions. So we can say it's, I mean, without any making sound, it can run. So that's what they get popularity in 1899. Then 1900, again this get popular. Even the government, US government also it's given approval for manufacturing these vehicles. So by knowing this technology transformation, Edison come into the picture. So in 1901, so they are planning to develop some batteries for the electric vehicles. Once they have come up with the batteries, then just they need not to have any tank to take the crude oil or gas in that. So that's what just they are trying to come up with the batteries. So in 1901 itself, Edison had tried to install the battery in the vehicle. So again in the same year, just they have come up with the hybrid cars. So in the hybrid cars means we can say it can be run with the gas as well as battery. So battery for to drive the vehicle, as well as gas engine also it's installed in the same vehicle. So that vehicle will be called as a hybrid vehicle. Then in 1910, around 1910, just the gas powered cars get popular. So why? Because gas is a very cheapest solution on during that year. Even if you go with the batteries, then the batteries are very higher cost. So that's what it's gas powered vehicles get popular during 1912. Then 1920, just better, yeah, they have go with the same gas-based vehicles because the gas prices are less during that period. But after 30 years of time, the gas prices are increased. So even it's skyrocketed. So that's what they plan to look for some alternatives for the vehicles for the transportation. So for that purpose, then they have come up with the even the oil-based, fossil fuel-based vehicles. Then 1971, if you look at it, NASA sent some manned vehicle to the moon. So that vehicle is a electric vehicle. So that during that time, they get a confidence that okay, this EV technology can be a game changer in the transportation. So that's what you can see in the 1973. The next generation of electric vehicles coming to the roads with the help of General Motors, and they have displayed that electric vehicles in the symposium. Then even one got GT car. That means it's like they are the taxi fleets. Just they have come up with the EVs. So these EVs also get popular in 1974 to 1977. Then afterwards, this electric cars, they found that electric cars had some limitations, kind of speed as well as the speed range. So because of that, the gasoline powered vehicles again coming to the picture. Then all the automobile companies, they had a research, and they have developed the various electric vehicles and hybrid vehicles. Even up to 2000, still electric vehicles are under research. So even some companies, they have released some of the passenger vehicles and they have failed, and they just then they closed down. Then they again they have run the vehicles with the fossil fuels. Then in 2006, the very interesting Tesla came to the picture during 2006, and they have come up with electric vehicles with 200 miles speed range. So earlier, people have claimed that electric vehicles are run with very less mileage and even very less speed range, or we can say the kilometer less distance. Then Tesla coming to this electric vehicle technology, then they made electric vehicle with the 200 miles range EVs. So that's what everyone having the interest on the electric vehicles. Even grown tremendously. Even if you look at it in 2013, just they come up with a nationwide charging infrastructure. So another bottleneck for EVs are charging infrastructure. So this charging infrastructure in 2009 to 13, they had a lot of charging stations in US during that time. Even in India also nowadays we can see that the Tata Power, ABP, even Power Grid, NTPC also come up with a lot of charging stations on highways. So even if we can say in residential and commercial buildings also come up with this charging infrastructure, then we rolled out. So then in 2010, again just they come up with the first commercial hybrid plug-in vehicles. So hybrid plug-in vehicle means just we can plug in and plug out the plug out what they say is that plug-in hybrid vehicles. So for this same EV technology, the Tesla have come up with a lot of battery technology that can cover the wide distance. So that's what even you could see that Tesla, the company started in 2006. In 2020, then Elon Musk, he's the owner of that. He's the #1 wealthiest person in the world. So even within a 14 years of time, so he became a #1 wealthiest person in the world. Even he overcome that Bill Gates and other people in the US, and he stepped up as a #1 wealthiest person within 14 years of time. So that's what they are looking for. The EV technology plays the tremendous role in the coming days. So during 2010 to 20, various manned vehicles, even they are trying to develop some battery technology, so that they are trying to bring down the cost of the battery down, so that the battery plays the crucial role in the EVs. So that's what even in India, if you can see, Tata Motors plays the very good role in the passenger vehicles sector. Even Mahindra also is same place, but Maruti, they do not have any technology with them. But but in a passenger vehicle sector, you could see that the Maruti had a huge market share, but Tata Motors had ahead of these companies, they are having the EV technology with them. Why? Because they have acquired some companies in UK, like Jaguar and Land Rover in UK. So with that help of that companies, they could able to launch the EV vehicles in India also. So they will get some market share among all the passenger vehicle players like Maruti and Mahindra and all. So when we come into the two-wheelers side, even there are two major two-wheeler players in India. One is Bajaj Auto and Hero Motor. So these two companies also, they are having their own EV models. However, nowadays there are a lot of small companies, they are coming up with the two-wheeler sector. So even Ola also, they are coming up with their own two-wheeler manufacturing unit in Tamil Nadu. And there are a lot of small companies, they are playing the significant role in the two-wheeler space. Then when we come into that commercial vehicles, for example, lorries, truck and all. So Ashok Leyland and again the Tata Motors having the huge market share. So these companies also, they are working on the commercial vehicle sector. But however, in commercial vehicle sector, the EVs are not giving the promising solution. The reason is again the battery and the distance. So for that, again, the government also having some initiatives to come up with the fuel cell based vehicles. That means instead of battery, they can have the hydrogen tank. With the hydrogen, they can able to run their vehicle. So that's what it's a fuel cell based vehicles. So even that also is get popular. So when we come into the transportation sector, there are 4 types of vehicles. One is pure IC engine based vehicles, those who are used by us now, and other is fuel cell based vehicles, hybrid vehicles, and electric vehicles. So in this combination, people are looking for the e-mobility, or we can say the electrification of the transportation. So why electric vehicles? When we talk about the electric vehicles, these 2 are the main reasons. One is to reduce the fossil fuels. So fossil fuels means we can say almost 80% of the oil and gas is imported in the crude oil. That will highly impact the economy of the country. So even we are depending on the other countries to import the oil and gas. Even if you can see the changes, that will impact much on the Indian economy. So that's what to reduce the fossil fuel usage, we can promote the that's what the government also is promoting the electric vehicles technology. And greenhouse gas emissions. So just we can see there are a lot of environmental pollution caused by this emission of the gases. So to reduce the, that's what even internationally there is some Paris agreement. Due to with the Paris agreement, every country has to reduce their carbon footprint, right? So that's what every country, they are trying to reduce the carbon footprint by adopting some new technologies. So even if we have here nowadays, this steel prices are doubled or tripled by within a 6 months to 1 year period of time. So do you know what's the reason behind it? Even you can see that the steel prices has increased 6 months to 1 year period. So what's the reason behind it? Do you have any idea? So why the steel prices has increased? I've heard that steel prices is doubled by 6 months period of time. Yes or no? Yeah. I can check it whether I can connect it or not. Yeah, I'm connected. So do you know what's the reason behind it? Yeah, you can tell any reasons. There's no issue. Even if it's wrong, I can correct it. Hello. Sir, am I audible or hello?
Sir, you're audible, sir.
Okay then.
Sir, you're audible only, sir.
Just I have small doubt. That's it.
You're audible, sir.
Yeah, sure. Okay. So why the steel prices has increased? There is some link between this, carbon footprint and this increase of the steel. So that's what the China is in necessity that they have to reduce their air pollution. So that's what they have shut down all their mines. So once their mines are closed, then the iron ore price has increased. So in a global market, so that's what in India also the steel price has increased. The steel is a commodity, so that commodity can be used for all the construction purpose, or you can say the infrastructure development. So that's what the steel price increase. Even every country, they are in a position to cut down the carbon footprint. So that's what there are a lot. I mean, they are trying to reduce the carbon footprint by promoting the electric vehicles, by promoting the renewable energy technologies, even this kind of to shut down the mining activities and all, they are trying to reduce it. So that's what this steel price has increased. So the another way to reduce that carbon footprint is to promote the electric vehicles. So even if we can look at that oil, the demand is keep on increasing. So even if we can see that the 2050, that demand is almost 70 billion barrels. So, but the production, oil production is only the 20 billion barrels. So what will happen? The demand, I mean, you could not able to meet the demand and supply. So the demand is higher. So obviously the price will increase. So once the price increases, then the transportation cost also will increase. So the only way to reduce the cost of transportation is to move into the electric vehicles. Then when we coming to this plot, you can see here this is the total CO2 from all the activities. So when you compare in 19th century to the 1950, the change in CO2 emission is very less. But if you look at here, 1950 to 2000, within a 15 years period of time, the CO2 emissions by all the activities has increased drastically. So to reduce this CO2 emissions, just we are focusing on the electric vehicles. Even you can look at here, the CO2, I mean, this graph means for CO2 from coal, and this one is CO2 by cement production. So here, these two, CO2 by oil is higher than the CO2 by coal. So that's what we are focusing on to reduce the CO2 emission from oil by promoting the electric vehicle technologies. Then when we come into the global air temperature from 18 2050. So here you can see here every century that every 10 years 2 degrees centigrade is raising 2 degrees centigrade every 10 years period of time. Even the 2010, by the same day, if you can see is 33 degrees centigrade. By today, in this year, we can see that this is a 35-degree centigrade. So every 10 years period of time, 2 degrees centigrade is increasing. So why? Because of this various emissions like CO2, carbon monoxide, and all. So this will pollute the environment as well as increase the temperature. So when we come into the Paris Agreement, as I mentioned earlier, just in the Paris Agreement, they have come up with that some of the objectives that they want to reduce that temperature rise below 2 degrees centigrade to the pre-industrial level. At the same time, not only 2 degrees centigrade, just they have some plan to at least by next 10 years, the temperature has to increase to 1.5 degrees centigrade. So for this, they are strengthening the ability of the countries to deal with the carbon footprint. So climate change is also it's one of the reason. Then another way of to reduce the carbon footprint is to increase the renewable energy technologies. So just we can say wind and photovoltaics are playing the huge role in renewable energy sector. So in India also, they are proposing to install 175 gigawatt of the power production from wind and photovoltaic. Excuse me. So in if we can see in 2050, they are targeting that at least 1/3 of the power coming from the PV and another 1/3 from wind. Only the 30 to 40% of the power generation from fossil fuels, so that we can able to enhance the energy security of the country. So energy security means we need not to depending on any import of oil and coal from other countries. Yeah, here when we come into that no fuel, no emission. So if you are not burning the fossil fuels, so there is no gas emissions. So that we can say at the same time, if you convert your vehicles into electric, then you need not to require any petrol or diesel. So we can say no fuel, no emissions. At the same time, when we move into electric vehicle technologies, the running cost of your vehicle is very cheaper. So that's what if you can see any advertisement of electric vehicles, they will simply claim that you can spend 1 rupee for 1 kilometer. So just your for traveling 1 kilometer, you have to spend only 1 rupee. But however, the running cost investment for, or we can say the capital investment required for electric vehicles are huge because of the battery. So how we can again make it cheaper? So that's a question here. So here for charging the EVs, instead of using the fossil fuel based power generation, you can use the renewable energy technology. So once you are generating the power from renewable energy technology, you can use that power for charging your electric vehicles. So in this case, you can able to nullify your charging cost. So that means that just you can increase the renewable energy installation as well as EV penetration. That can come into break-even point, so that your running cost of your electric vehicle is 0. So that's what they are claiming here in the last point. That's what even the MNRE, Ministry of New Renewable Energy, also they are reducing the electricity cost by one. I mean, do you have any idea how much they are purchasing from the power producers. What is the cost of electricity they are getting from the power producers? For example, if they generate the power from photovoltaic or wind, is a low bidding cost below 2 rupees. Below 2 rupees, they are getting the power from the power producers like Tata and Adani, and they are selling to the public. They are selling to the distribution companies. Then they are selling at higher cost to the consumers. So, but from the power producers, they are getting 2 rupees per unit. So that's less than 2 rupees per unit. Even recent uh, bidding cost is below 2 rupees. Even if you can check it with the MNRE website, you will get to know the lowest bidding cost of the electricity from wind and photovoltaic. So wide range of speed. Yeah, only the Tesla cars has given the wide range of speed. For a single charge, you can able to travel 300 to 500 kilometers. Even now, Tata Nexon also they are claiming that you can able to travel up to 300 kilometers per single charge. And Tesla, their range is from 300 miles to 1,000 miles. So accordingly, the price of the car also is increasing. Even next year in 2022, the Tesla going to introduce their cars in India also. So that's what there are a lot of news going on. You can check it out. Even there are some rumors that they are going to tie up with Tata Motors to marketing in India. We don't know how that things will change, but by looking at these things, we can strongly believe that EV plays a huge role in the coming decade. So again, if the numbers will increase, again the speed range also will improve with the time. So next one is health benefit. Yeah, if you are reducing the gas emissions, you can able to save a lot of cost. What cost? If here you can they are saying that if you are getting the better air quality, you can able to improve your health. So once if you improve your health, the cost by the air pollution can be decreased. That means it's very simple. It's a win-to-win situation to the public as well as the government. So how means if you are reducing the carbon emissions, the amount which you are spending for the hospitals will be reduced. So that cost can be compensated here. So that's what they are saying, that cost by the air pollution can be decreased. At the same time, when you are driving the electric vehicles, you won't get any sound because all machines, or we can say the engines are electric, so you won't get that much noise in it. Yeah, because you are not having the, you'll get very less noise. At the same time, even if you are having a less moving parts in your any equipment or any system, then your maintenance cost also will be reduced. So here you need not to have any lubricant oils, or you need not to have the periodic maintenance for the electric vehicles as like your IC engines. Even the IC engine also, the maintenance cost will differ from petrol engine to diesel engine. Even if you come into electric vehicles, you need not to spend much maintenance cost for it. So that's what they are claiming, that the maintenance cost is very less as compared to fossil fuel based vehicles. So what are the advantages in terms of electrical system infrastructure? So suppose if you want to promote electric vehicles, you need much of charging stations. But in India, we could not able to see the charging stations in even the fuel station, like a fuel stations. if you're having a much charging stations on the highways, like your petrol pumps, then there is a chance to promote the electric vehicles in a faster way. So that's what these companies like Tata Power, Adani Power, NTPC, Power Grid and all is coming to the picture to install the charging stations. So what are the advantages of having this charging? I mean, if you're connecting your vehicles with the charging stations. So you can take the example of your home. Just I can take the example that I'm staying in some apartment. So in an apartment, I can say some 100 houses. So for the 100 houses, almost we can take 80% of them will use the passenger vehicles. So 80% of them are having the cars. So that 80% of the cars will be parked in the parking lots. Am I right? So out of this 80%, you can consider the 20% maybe out of station. So almost 60 to 65 cars will be parked in the parking lots. So at that time, they will connect their cars with the charging point. So in your car, just you are having the battery. So 60 cars. So just in your apartment alone, you are having the 60 cars. So this 60 cars, just we can add up all the batteries. So just you will get the huge capacity of the battery. So this huge capacity of the battery can contribute to the electrical grid ancillary services. Like ancillary services means like if your electric grid having the reactive power requirement, so that reactive power can be supported by your electric vehicles, so that we can able to maintain the voltage stability in the network, right? So one is this ancillary service, reactive power support. Another thing is it will play the huge role in the demand response management. So how we can say demand response management means, for example, if you're having the variable, I mean, here in India, we are having the fixed tariff, but if you're going to some countries, they are having the variable tariff structure of electricity. So in a variable tariff structure, during a peak period, your electricity cost is higher. During peak period, electricity cost is higher. During a off-peak period, your electricity cost is less. So what we can do is just we can play with the demand response management. Means just whenever the power deficit or whenever the power required by the grid, that time you can sell your power at higher cost during the peak period. So you are selling at higher cost, and during the off-peak period, the electricity price is less. So during that time, you can able to charge your batteries. So if you take the if you are taking the average cost of this charging and discharging, the consumer get benefit out of it. So that's what we can say. This EV plays the huge role in the demand response management algorithms and all. So that's what even for an electrical engineer, we are having a lot of scope to work on system level. So even if you are interested to work on the component level, then we can able to develop a lot of power converter topologies for charging and discharging. So even the bidirectional converters also plays a huge role here. So we can able to play with the power electronic stuff if you are interested in the component level development. For system level development, obviously for a single apartment, I'm saying 60 cars. Just think of it. Even around 30 to 40% of the population may have vehicles. So that if you can able to aggregate this all the vehicles, then this will play the huge energy storage facility to the electrical grid, right? Next is when we come into the safety improvements. Yeah, as like other vehicles, in electric vehicles also, just we are having the safety. So here, just we are using the batteries. So batteries also can have the explosions, but as compared to gas and petrol, this having the less explosions. The probability of explosion is less in the case of battery as compared to gasolines, or we can say even sometimes they say hydrogen tanks in the fuel cell vehicles. So when we come into the EVs, just we can able to classify the EVs as vehicles as IC engines, hybrid vehicles, and battery operated vehicles. So in the IC engines, purely it's based on diesel and petrol cars. Nowadays, what we are using it. So here we are using the internal combustion engines, and some small micro hybrid also there. So small hybrid means during the just they may implement some regenerative braking in it, so the energy have generated during the braking that can be stored in the battery for the like auxiliary applications, like whatever the lightings and other services you are having in a car. For that purpose, you can use that energy. So that's what they say is a micro hybrid. It's not fully hybrid, it's a micro hybrid. So this is our IC engine side. So when we come into the hybrid electric vehicles, so there are mild and full hybrid vehicles. So in a mild hybrid vehicles, again the percentage it's matter. So we can say it's that 20% of the energy is used by the electric, driven by the electricity. So in the full hybrid vehicles, that's depending on the topology, whether it's a parallel connected or series connected, or we can say the percentage of electrification in your vehicles, it will vary. So that and all we'll see in the future slides. Then another thing is battery-based vehicles. So here these BEVs are the fully EVs. It's not these and all. It's IC engines are there in this ICEV and HEV, but in BEV is a pure electric vehicle. So that we can say is a battery operated vehicles. So instead of pile tanks, we are having the battery as a source here. So it's a battery electric vehicles, or you can say it's the fuel cell vehicles. So instead of battery, just we are having the fuel cell stacks. By using the fuel cell stacks, you can able to generate the electricity. Then that electricity can be used to run your electrical motor in EVs. So here the source is hydrogen. Just we are having the hydrogen tanks on your vehicle. So that hydrogen tanks can supply the hydrogen to the fuel cell stack. Then fuel cell stack generate the electricity. Then that can run your motor. So this also comes under the full EV. That's called the FCEV, fuel cell electric vehicle. So when we compare the electric vehicle with IC engines, you can see the fuel emissions, gas emissions. So in the IC engines, you can see here the CO and CO2 emissions are higher, but in the battery operated vehicles or fuel cell vehicles, just we can have the less pollution. So there is the less pollution compared to combustion engines. So how we can classify this EV and IC engines? So just here you can see here for all the vehicles, whether it's hybrid vehicles or IC engine vehicles or electric vehicles, you can see here the energy resources are fossil fuels only. So we can see here oil, gas, biomass, coal, wind, solar. Just we are using all energy resources. So all your vehicles, whether it's a hybrid vehicle, IC engine, or fully electric vehicles, all are operating from this energy resources. So here, if you are saying it's a fuel cell vehicle, the fuel cell vehicle alone, you can say it's a hydrogen-based vehicle. So here you are not using any fossil fuel. So just we are using hydrogen as a fuel here. So in this case, when you are coming to the electric vehicles and hybrid vehicles. These groups are called electric vehicles or hybrid vehicles. So in this electric vehicles and hybrid vehicles, just you are generating the electricity, whether it's locally or centrally. Centrally means it's just we are generating the power in the power plants, and that electricity you are using for charging your battery in an electric vehicle. In a hybrid vehicles, just we are having the IC engine and the battery over there. So that comes under the hybrid vehicles. So in that also, just we are using the electricity. Mainly just we are using the electricity to drive the vehicle. So earlier cases, just in IC engines, just we are using the oil directly on the vehicle, and you are running your IC engines, right? This is the comparison of EV and IC engines. So this will give a very good comparison why we are going for electric vehicles. So this is the efficiency which are given here are tank to wheel efficiency. So when we talk about to justify the electric vehicle technology, there are two efficiencies. One is tank to wheel efficiency, another one is wheel to wheel efficiency. If you compare the tank to wheel efficiency and well to wheel efficiency of IC engine and electric vehicle, you can easily justify that why the electric vehicles are superior than the IC engines. So you can see here the battery operated vehicles, that is fully electric vehicles. So just we are using the electricity to charge the battery. So there you can have 2% loss. So that 98% of the energy can be used to drive your electrical drive person, right? So then wheels. So when you are moving your energy, so you are losing 6% here efficiency in a battery operated vehicles. So FEV or FCEV, fuel cell based electric vehicles. So here your source is hydrogen. In fuel cell electric vehicles, hydrogen is a source. So fuel cell stacks, the efficiency of the fuel cell is 55%. So just then again you are using the electricity to drive your electric. At the end of the electrical drive, you will get the 44%. Then again just 4% loss, so 40% will get it on the wheels. If you look at the IC engines, petrol, 20%. If you are getting the 20% efficiency here, so again you are losing 3%. So when we compare the battery operated, see that the battery operated vehicle having the higher efficiency of 72% when we compare with the fuel cell vehicle and IC engine. So the least efficiency by IC engines. Again, if you look at it, people may ask that, okay, electricity also I'm generating from the fossil fuels, and instead of generating the electricity in that thermal power plants or in other way gas power plants, just I'm using that oil on my tank, in the tank of my vehicle, and I'm using it. So just you can see here the efficiency difference. So the same crude oil, that is a source for your EV as well as IC engines, the same crude oil. Just in an oil refinery, you will get the higher efficiency once you are here also the same way, but instead of directly just here you are transferring to the vehicles, so you'll get 13% efficiency. Here the same oil can be used in the thermal power station, so the power generation 36%, and we are getting the transmission and distribution losses and charging. During the charging, you'll get some losses. Then the efficiency here you will get 18%. So when we calculate the well to wheel efficiency, so from the oil well to wheel efficiency on your vehicle wheel. So if we calculate that efficiency, then the battery operated vehicle will give the 18% efficiency, but here IC engine 13%. So 5% is more. So that's what if you calculate the number of vehicles used by any country, if you are having the 5% energy efficiency, that is a huge one. So that's what government also putting a lot of interest to promote the electric vehicles nowadays. So this one will provide. So how much hybridization you are doing it. So even if you are increasing the hybridization level, the cost will increase. Obviously, if you are saying it's a full hybrid vehicle, the cost of the vehicle will be higher. At the same time, if you are fully hybridized your vehicle, the power level also increase. At the same time, your fuel efficiency will increase. So the fuel required for that fully hybrid vehicle is very lesser than the IC engine or micro hybrid vehicles. But cost will be higher. Initial cost is higher, but you can able to reduce the cost, fuel cost. We can say it's 20 to 30%. So when we come into the state of the art EV, so there are when we talk about the electric vehicles, we are the motor drive technology. So when we talk about the motor drive technology, so there are different types of electric drives used in the electric vehicles. We can say it's the AC drives and DC drives. Most probably we will use the AC drives in the electric vehicles. Then next one is battery technology. So if you want to reduce the weight of the electric vehicle as well as the speed range and distance with single charge. So for that we are using the different batteries. Earlier just we have used the lead-acid batteries. Now lithium-ion batteries are the best candidate for this electric vehicles, and some other technologies also they are coming to the picture. We will discuss in the future slides. Then charging technology. So here again the power electronic engineers plays a huge role, the battery charging technology. So here what type of charger we require. So what type of charger means there are two types. One is fast charger and slow charger. Then again we can classify that charger as unidirectional and bidirectional chargers. Unidirectional bidirectional charger means, so if you want to by considering the future, if you want your vehicle to participate in that demand response management algorithms, then you should have the bidirectional chargers. Then only you can able to charge and discharge your batteries depending upon the requirement of the grid. So next one is unidirectional chargers. You can use that chargers only for charging your batteries or charging your vehicle. You could not able to discharge your vehicles to participate in the ancillary services of the power grid. So here the power electronic engineers plays a huge role to design and development of the chargers. Here vehicle to grid technology and grid to vehicle technology. So as we discussed in the battery charging technology, if you are having the bidirectional chargers, you can able to participate in the V2G and G2V technologies. V2V means just we can able to discharge the battery to participate in the DRM. Then grid 2 vehicle means just you can charge your batteries. So that's what V2G and G2V. Not only the power system engineers having the lot of they can develop a lot of demand response management algorithms as well as energy management algorithms to the power system. They are having the huge potential to work on these technologies. When we talk about the motor drive technology, this is very core in the EVs. So which electrical motor? So here in the electrical drive, the electrical machines plays a huge role. So the electric motors, when you are selecting the electrical motors for your EVs, then you should check following points. So that electrical machines should have a high torque density as well as power density. So high torque density means if you want to start your electric vehicles with a high power density, if you want to go at a high speed, the power density will be decided. At the same time, your electrical motors should have the high load condition. That's very much required. So it's not kind of constant drives you are using the industrial applications. So here speed range will be from low to high. So from low to high. So during that low to high speed range operation, you should have the 3. Then why constant power operating capability? So sometimes if you are going in a highway, then your electrical drive can operate in the constant power mode, and high torque capability for hill climbing, as well as if you are start your vehicle with the heavy load. So that time this high torque can be useful, and high reliability, low noise. Obviously, if you're using the electrical drives, nowadays if we can see that a lot of drives coming up without any noise. It's very reasonable noise. But at the end of the day, the cost also is matter. So just for reducing the system cost, you should get the electrical drive with the reasonable cost. Even in industries, there are a lot of electrical drive companies available. They are providing the very reasonable cost to the drives. So even if we say it's the ABB, Crompton Graves, they are giving the very reasonable drives. Even GE also in that technology. So here some additional requirement of electrical machines for hybrid electric vehicles. So in this case, during the regenerative braking, it should have the high efficiency power generation, so that we can able to save the energy in that case. And during this wide speed operation, it should maintain the good voltage regulation at the DC links. So DC link between your inverter and the battery charger. So that just we have to maintain the good voltage regulation. So even if you change the speed from low to high, or if you are driving your vehicle with low load to high load, you should maintain the constant voltage at the DC link, so that we can able to achieve the precise control, speed control in the electric vehicles. So this again, if you are talking about these properties that can be integrated with the engine. So here the engine means it's a electrical drives. So when we come into the motors, there are two types. One is commutator drive, another one is commutator lace. As we discussed in our electrical machines, the commutator lace based machines are getting attention with the EV technology. Even if you are going with the commutator based machines, then again just you have to give a lot of attention to the maintenance. So that's what people will prefer commutator lace based machines. So when you come into the electrical machines, just we are having the two types. One is commutator based and the commutator lace. So in the commutator based machines, just we will get all the DC machines. So in the DC, all the DC machines, just we are having the commutators, so that we require a lot of maintenance. So when we come into the commutator list machines, all the AC machines are all the AC machines come into the picture. So during this speed control of these machines, always you require the power electronic converters. That's very important with all these type of machines. So in all the machines, you should require the power electronic converters. So here, induction and synchronous machines are not just we are having these drives available in the market. But when I come into the electric vehicles, they are trying to use double salient machines and vernier based machines. So in the double salient machines, just we are having the salient poles in the stator and rotor. So the disadvantage of the double salient pole machines are speed range. So here you will get only very less speed range. So when we come into the vernier machines, so just they will use the in a vernier machines they will use the vernier effect to amplify the output torque. So here your output torque is higher during low speed conditions. So that's the advantage of vernier machines. So that's what they can say: low speed, high torque, direct drive applications. So during the low speed conditions, you will get a higher torque. So here also you need not use any kind of gearboxes. You can directly vehicle. So that's the advantage of this vernier machines. So in this, there are a lot of technologies with the machines with the axial flux morphology, linear flux morphology, and transverse flux morphology. So in this, mainly in the electric vehicles, they will use axial flux morphology, and rarely they will use the linear flux morphology and transverse flux morphology. The reason is to integrate the electrical machines with the vehicles. So that's what they won't prefer linear and transverse flux morphology. They prefer axial flux morphology. So this having the advantage of high power and torque density. Here again, because of this axial force, it won't fit into the pancake. So that's what normally this one, when we come into the design of drive lines, this will create a problem. So otherwise, this axial flux morphology is best suited for electric vehicles. So this linear flux morphology normally just so is very less attractive to the EVs. The transverse flux morphology also not suited for EVs, but it will provide a very good torque density. But here the machine structure and all is very complicated, so they won't prefer this type of morphology for EVs. So when we come into the again coming to the propulsion system, just we are having the two technologies: ISG, integrated starter generator, and EVT technology. Even you can see now in your passenger car also you can able to see that EVT, electric variable transmission. So these technologies normally they will talk about when we come into the hybridization of your electric vehicle. So if you are combining your electric, electrical motor and IC engine, then this type of terms can able to hear it. So because of this integrated starter generator, you can able to black start your vehicle, as well as whenever you are going for hill to low, save the energy in this case of ISD based systems. Then here in the EVT also, just regenerative braking, even the block start and all is possible. Okay, this general is coming to the drive line. So in the drive line, how we are transmitting these things, and just directly going to the energy source technology. So in energy source technology, if we are talking about the batteries, so here we mentioned the four energy sources. One is batteries, ultra capacitor. To the energy density perspective, the batteries will provide the high energy density. When we talk about the capacitors, it will provide the high power density. So battery will provide the high energy density. Capacitors will provide the high power density. So if you hybrid, get the best characteristics of the battery, characteristics of high energy density, and capacitor having the high power density. So if you want to increase the distance, for example, for a single charge, if you want to run your electric vehicles for 300 to 500 kilometers, then the best candidate is battery. For example, if you want to start up your electric vehicles with heavy load, or if you are going with the down to high in the hills, so that time you need the high power. So high power with a shorter period of time. But here you require the power for the longer period of time. So for getting this both the characteristics, best you can hybridize these batteries and ultra capacitors. So you will get these characteristics. Then flywheels. Normally in electric vehicles, they won't use the flywheels. Why? Because the flywheels is like our electrical drive. Just what you can do is, best example is, if you're having the spring, that spring you can tighten up, then you can release it. So during the tighten up, you need to give some small energy. While releasing that spring, just it will it will provide the high energy or high power. So the flywheel also is the same way. In your electrical drive, if you are having that high inertia, in your electrical drive, that by using that inertia, you can able to store the energy. So normally this type of energy source, they will not use in the electric vehicles. Fuel cells, normally they will use, because hydrogen you can able to use it in your vehicles. Okay, I skip those slides. So these are the different types of batteries, and energy density and the power density is given, as well as life cycle and cost. So normally look into the energy density and cost, life cycle. So based on that, the best candidate is lithium-ion battery. So you can see here, the lithium-ion batteries having the good energy density, as well as life of the battery also is good as compared to others, and cost is little higher than the zinc and air-based battery, and other type of battery. We are of the EVs. So if you are choosing the lead acid batteries, again just we have to again the maintenance cost will be higher. The energy density also is lower than the lithium ion batteries. So that here the best candidate is lithium ion batteries for the EVs. So I'll skip these slides and can go to the battery charging technology. Again, the battery charging technology, whether you are going with a bidirectional converter or unidirectional converter, this is one perspective. In another perspective, whether it's onboard charger or off-board charger. So whether you are to plug in your wire in the socket or you have to carry the charger with you. So that's the two types of onboard off-board charger. Then another thing is wireless and wired charger. But even the technology is not matured, EV technology is not matured. Once the EV technology matures, then we will talk about the wired charging or wireless power charging. So wireless power transfer, again the wireless power transfer also the efficiency is very poor. That also is depending upon the distance between your receiving coil and sending coil. So even if your receiving coil is very close to your sending coil, then you will get some good efficiencies, 90 to 95%. If your distance is more than 2 meter or 5 meter, then again, if you calculate the well to efficiency mature, DD technology mature, then we'll talk about the wireless power charging and all. So when we talk about the vehicle to grid, yeah, it will provide a lot of ancillary services and everything, so that can check it out. So when we talk about then you should have the aggregator. So that can be implemented by the distribution company. So as a individual consumer, we cannot play with that. So this involves the infrastructure development that can be taken care of power companies. So because of this aggregator and all, that means whenever you are parking your car, just you have to connect with your charger cable, so that based on the number of vehicles on the particular area or in the particular building, you can able to aggregate it. That will provide the ancillary services to your grid. So this can be done by the distribution companies. So these involves peak saving and how we can able to play with the demand response management algorithm. So by aggregating all the EVs in your network, so that if you're aggregating all the EVs in your network, you can able to play with the demand response management in the power system perspective. So these are the testing standards. If you are really interested to check with the testing standards, please go with that. There are European and European standards standard, as well as US standard and Japanese standards are there. Normally, all these tricycles will be checked with these standards before coming out of the company. So just if you are really interested to check with these tricycles, please go ahead with that, these slides. So these are the So when we talk about these are the hybrid vehicles. That's what we are having, the battery as well as IC engines. So the battery can operate your electrical motors that can be connected through the inverters. So there is 50 kilowatt range. So there is 20 to 28 kilowatt permanent magnet machine that can be connected with the planetary G set. So generate the power and can be charged your battery here. So during the vehicle operation, so both can support to drive your vehicle's wheel, right? So that's what these are the specification of your some 200 examples are there. You can check it out, which one having the, different parameters. So depending upon the acceleration means within 7.9 seconds, you can able to reach the full speed range. So that's what it's a pickup. And we used to say it's a pickup, right? So this range for a single charge, you can able to travel 230 kilometers. Then the total power of your electrical drive is 110 kilowatt. That's the maximum torque is 320 Newton meters. And when we talk about the battery capacity, capacity 40 kilowatt hour. The same way, normally when we choose our vehicles, we'll say it's a petrol or diesel variant. The same way here also we have to check it. So how much pickup you require, and for a single charge, how many kilometers you have to run, and how much kilometer to run for a single charge. So what is the
Sir, Vijay Kumar, sir. Vijay Kumar, sir. Vijay Kumar, sir. Sir, it is not audible, sir. Vijay Kumar sir. Vijay Kumar sir.
Hello,
Sir.
are you able to hear me?
Yes sir. Now it is
Hello.
clear sir.
Actually, it's a time. It's showing that it's the meeting was timed out, so that's what I was logged out automatically. I don't know what's the reason.
Okay, okay. So we were online only, sir.
Now I am in online. So just
Yes sir. Yes sir.
I finished my part. So just we can. So I don't know where I have left. Even sometimes I have given a talk for 2 to 3 minutes, right?
Okay,
Even
sir.
I could not able to see that whether I have it or not.
So we'll go for the questions, sir. If the participants have questions, you can address.
Yeah, sure. Yeah,
Okay, sir.
sure. We can go for a question. If audience having any doubts or any questions, please ask them to post it here.
So we have a question. In e-bike, we accelerate the motor like an IC engine,
Okay.
and sudden decelerates as per road condition. At this condition, how the speed variation in EV is managed?
So that's what I mentioned here. Depending upon your, cost of your bike, the acceleration will change. So sometimes some of the bike, if you're some of the bikes, they will provide the acceleration. That means if you want to reach 100 kilometer, that may give within some 100 seconds or 200 seconds. So just we have to see the specification, acceleration specification, if you want to really a pickup. Normally in IC engines, we'll say it's a pickup, right? So if you want to overtake some of the vehicles, then you require the very good pickup with the, there is some difference between your Maruti 800 as well as your, Honda or your, high-end cars. So the same way here also, just we have to check out the acceleration. So that acceleration, give that specification. So that's what when I saw the slides of comparison of all electric vehicles, there they mentioned the acceleration. So that acceleration plays a huge role.
How about the braking system in e-cars? Will it be good compared to disc brakes in normal cars?
Disc brakes and as well as if you are talking about the disc brakes, so this will that will provide a very good braking system to use. That's the kind of mechanical braking. So with that braking, you cannot to save the energy. Just you dissipating the energy as a heat in this displays. But when we come into that regenerative braking, just you are generating, just you are sending back that energy to your batteries. Just you are generating the power by applying the braking, then we are saving the energy over there. But when we come, mechanical brakes will give very good brakes to you. But in energy point of view, regenerative braking is the best, right? When we talk about the Tesla and all, they are having check. Is my voice? Hello.
Sir, yes, sir. It's clear,
Hello.
sir. It's clear.
So, he's asking about regenerating when we. It's clear, right? So, okay. So, any other questions? Yes, a few more questions. Yeah, graphene battery. Yeah, one person asking about the battery technology. As far as I know that just they will use the graphites as the electrodes in the batteries, right? So in the electrode, they are having the different types of materials. But here, normally in the lithium-ion batteries, they use the graphite as, lead-acid batteries, the graphite normally they used as the electrode. So here, even no, depending upon again the performance, and you are saying the energy density. So when we come into the lead acid battery and lithium ion batteries, the lithium ion batteries having the high energy density than the lead acid batteries. So for a small size, with the same size of both the batteries, you can have the high energy in the lithium ion battery. So that's what people they prefer the lithium ion batteries for electric vehicles. Even in India, there are two major players for battery technology. One is Amar Raja batteries, Excite batteries. So apart from these two battery manufacturers, even India, in a Make in India scheme, even Tata Chemical also they are having the huge plant in Gujarat to manufacture the lithium cells. So these lithium cells normally we are importing from the China. We are mostly depending on these lithium cells from China. To avoid that, even the Tata also planning to go with a huge plant in Gujarat with for lithium cells. So that's what even this one. Even Tata Chemical, they have the MOU with the STRO. So they are having the battery technology. With that, they are coming up with that plant. Even Amar Raja also with the IIT Madras tie-up, they are having some R&D unit. So they are also in the race. How ultra capacitors work in EV? What is Sorry, I'm not getting what is mechanics in EVs. So ultra capacitors, that's what I already told you. If you are talking about the battery will provide the high energy density. Hello, are you able to hear me?
Sir, yes, sir. Yes, sir.
Yeah. When we talk about the ultra capacitors provide the high power density. Suppose if you want acceleration, so within a 100 seconds, you want a full speed. That time you require the huge power. So that's what for providing that huge power, the ultra capacitors will be provide the huge power within a short period of time. But batteries will not provide the huge power with short period. So that's what ultra capacitors having the high power density. During the acceleration, these ultra capacitors will be used in the EVs. These ultra capacitors also normally used in our IC engine based passenger vehicles. During the starting, during the ignition period, you require the high power, right? So to provide that high power within short period of time, these ultra capacitors are used in the starting of our normal vehicles also. Yeah, sure, Dyson. Thank you.
Thank you, sir. Since there are no more questions, so they're asking for your contact details, sir.
Yeah, you can write it to me on Vijay Kumar at IIITDM, or you can visit IIITDM website. You can able to find the contact details.
Okay, sir. Okay, sir.
Or I can type it here. That would be better. So I can type my mail ID here. So if any doubt, you can mail me. So I'll try to answer it.
Thank you, sir. If since there are no more questions, I would like to end the session now. At this
Yeah,
juncture,
sure. Thank you all.
the KPRIT Principal C sir and HOD sir and the organized committee, I would like to thank you for the wonderful session you have given us. It was an exhaustive session, sir. We had a brief description of various points you have discussed about electrical vehicle. We are really thankful to you, sir. Hope we will meet you again in some other sessions too, sir. Thank you, sir.
Yeah, sure. Thank you. Thank you all.
Thank you, sir. We'll end the session now,
Yeah.
sir.
Yeah, sure.